Dear students, today we are going to see the class 10 mathematics unit of polynomial. Here we are going to see the definition, types of polynomials based on its degree, value of polynomial, zero of polynomial, and geometrical meaning of a polynomial. We shall start with the definition of a polynomial. An expression of the form p of x is equal to a0 x raised to 0 plus a1 x raised to 1 plus a2 x raised to 2 plus 1 plus an x raised to n, in which the variable involved have only non-negative integral exponents is called a polynomial in x. Here a0, a1, a2, so on to an are called as constants or real numbers. Here, whereas x raised to 0, x raised to 1, x raised to 2, so on to x raised to n are called as variables. The polynomials can also be defined in simple words, that is an expression in which the variable will have power of whole number, which means the power of the variable will contains 0, 1, 2, 3, so on. Now we shall see which are the polynomials and which are not the polynomials. The first set, which are being called as a polynomial. The first number 2, that is a constant, is a polynomial. The second one, the variable x, is also a polynomial. Third, the combination of a constant and variable is also a polynomial, whereas the last example, x raised to 2 plus 2x plus 3, is also polynomial. These are all called as a polynomials. Why? Because its variable consists of power of, that is, of whole number, whereas when you see those are not polynomial, in that first example is 1 by x. Here 1 by x can be written as x raised to minus 1. Here the power is negative, so that cannot be called as a polynomial. So straightly it has been noted that the variable must have the power of whole number. Next example, root of x. The root of x exponential form is x raised to 1 by 2, where x raised to 1 by 2 has a power that is fraction, so it cannot be called as a polynomial. Third example, x raised to 2 plus x raised to 1 by 3 plus 2. Here the power x raised to 1 by 3 is again a fraction, therefore it cannot be called as a polynomial. The final example is x raised to minus 1 plus x3x minus 2. Here the variable power minus 1, which cannot be a negative, therefore again it's not a polynomial. Now the next part, that is the degree. The definition of a degree states that the highest power of variable in a polynomial is called as degree of a polynomial. The highest power of a polynomial of what? Highest power of a variable in a polynomial is called degree. Now polynomials, there are two examples of a polynomial and its degree. The first one, x raised to 2 plus 2x minus 3, its degree is 2. Whereas next example, x cube minus 4x raised to 5 plus 7. Here variable x has the highest power 5, therefore its degree is 5. The next part we have to learn is types of polynomials based on its degree. The first type is constant polynomial. The second type is linear. Third type is quadratic. Fourth is cubic. And the fifth is biquadratic. The types of polynomials which are based on degree, among them, that is the first one, that is constant polynomial. A constant polynomial are all numbers which are being called as constant polynomial. For example, 2, 9, 20, etc. All numbers are nothing but constant polynomial. Along with those types of polynomials, we are going to learn about degree and its zeros. Here degree of a constant polynomial is 0. Why? Because if you take example of 2, along with that, if I write a variable x, I can have, if I need to get 2, then I must write that power of a variable is 0. Therefore, the degree of constant polynomial is always 0. So, the number of zeros depend upon the number of degree. Simultaneously, the zeros of the constants are 0. Therefore, the number of zeros cannot be existed. Therefore, the zeros are not present for a constant polynomial. Second type, that is linear polynomial. Its standard form is ax plus b. Its degree is 1 and its number of zeros are 1. Here the linear polynomial standard form ax plus b. Along with that, we need to write the condition that a is not equal to 0. The third type is quadratic polynomial. Here the standard form is ax square plus bx plus c. Its degree is 2 and its number of 0 is 2. Previously I have told that the number of zeros depend upon number of degree. Cubic polynomial. Cubic polynomial, its standard form is ax cube plus bx square plus cx plus d. Its degree is 3 and the same the number of zeros are 3. The fifth one, that is biquadratic polynomial. Its standard form is ax raised to 4 plus bx cube plus cx square plus dx plus e, and its degree is 4 and the number of zeros depend upon the degree, that is 4. In generally, if you want to talk about that, how many degrees, suppose if you have a degree of n, then how many zeros it can have. So in general, a polynomial of degree n has at the most n zeros. So what is the meaning of at most n zeros? For example, if you take a quadratic polynomial, here we have a degree is 2 and the number of zeros are at most, can have at most 2 zeros. So at most 2 0 means a quadratic polynomial can have a 2 zeros, 1, or it may not have a any 0. So it can have 2 zeros, 1 0, or it cannot have any real zeros. That is the meaning of at most 2 zeros. The next thing what we have to learn is value of a polynomial. If p of x is a polynomial in x and k is any real number, then the real number obtained by replacing x by k in p of x is called the value of p of x at x equal to k, and it is denoted by p of k. So here nothing is complex to understand. Here p of x is any polynomial and this x is being replaced by this constant, that is k. Here what he has written in the definition, that the real number obtained by replacing x by k in p of x, the number which you got is nothing but the value of a polynomial. For example, if there is a polynomial p of x is equal to x square plus 3x plus 1, if you replace that variable has a constant x equal to 1, that what we have written here k, that is replacing x by k. Here our k is 1 and we are substituting that 1 in this polynomial, that is p of x is equal to x square plus 3x plus 1. By replacing x equal to 1, you get p of 1 is equal to 1 square plus 3 into 1 plus 1. When you simplify, you get p of 1 is equal to 5. So the result 5 is nothing but the value of p of x at x equal to 1. Ultimately, if you want to remember what is the value of a polynomial, in simple way we can understand that when you replace that variable of x as any constant, if the result what you get is nothing but the value of a polynomial. Next, 0 of a polynomial. Zero of a polynomial, it may be also told as zeros of a polynomial. Definition: if p of x is a polynomial and k is any real number such that p of k is equal to 0, then k is called the 0 of a polynomial of p of x. Here, what is the meaning of this definition? When you replace the variable x by any constant k, then if you get the value as 0, then that constant is nothing but 0 of a polynomial. So we can easily understand by using this example. If p of x is equal to x square minus 2x plus 1, if we replace that x as constant 1, then when you substitute this, you get p of 1 is equal to 1 square minus 2 into 1 plus 1. So when you simplify it, you will get the 0. So for what value what value of x that is constant, you get the result as 0, then this constant is nothing but 0 of a polynomial. Here in p of x, that is in this polynomial, 1 is called as 0 of a polynomial. If we get the value of polynomial is 0 for any constant, then that constant is nothing but it is called as 0 of a polynomial. The next thing what we need to learn is the geometrical meaning of zeros of a polynomial. In earlier we have seen that there are different kinds of a polynomials, that is linear and quadratic and cubic and biquadratic. For linear, in which way can have a graph? Suppose if it is a Cartesian plane, this is a x-axis and it is a y-axis. Suppose we can have a curve in this way of a linear polynomial, that is called a straight line, whereas in a quadratic we can have a graph in this way. Suppose if it is a Cartesian plane, so we can have a graph in this way, which is called as parabola, and it has maximum 2 solutions which has been intersected x-axis. Then cubic polynomial graph can be obtained in a Cartesian plane in this way, which is called as cubic curve. It can have at most how many zeros? 3 zeros, that is here 1, here 1 and here 1. That the curve has been, how many times the curve has been intersected the x-axis, it depends upon that thing. Suppose if your graph is in this way, so how many zeros it can have? It is inverse parabola, you can have 2 zeros. Whereas suppose if your graph is in this way, so you can count that in how many ways in how many times it has been intersected the x-axis, 1, 2, 3 and 4. So we can say that it has a 4 zeros. Thank you.